And welcome everybody to the Daily Space Weather. We've got a geomagnetic storm subsiding. Lots of stuff to cover. Let's get into it. Here at the Smash News Network, least busted, name and news. Here's the sun in 304 angstroms. There was a C-class solar flare. In the past 24 hours, you'll see it coming out of Sunspot 2882. The current most active region on the sun. It was a coronal mass ejection that struck, making it up to a KP6 in the middle of a coronal hole wind stream. And we're seeing that start to subside now. I think we still do see very strong fields. Here's a magnetogram from the SDO. Two sunspot groups currently on the Earth-facing portion of the solar disk. This one's setting up here. That'll lose its name today because it will set in the northwest. This one here, Sunspot 2882, remains beta-gamma class and likely to produce additional major solar flares. Here's a full disk view in 171 angstroms. My favorite wavelength. It shows the lower corona, which is full of magnetic looping of ionized iron, which is what this is. The emissions of ionized iron, 171 angstroms from the Solar Dynamics Observatory. Lots more stuff to blast through today. Let's get to it. The radio flux only at 89, so it's the most proportional data set to sunspot number in terms of measuring solar activity, discovered in 1947 by some Canadian radio users. Using some World War II equipment, they discovered the 10.7 centimeter radio flux. It's been monitored ever since. Anyway, there's the one-year chart of that from Solon.info. The black line's the radio flux. It's at 89 at the moment. And at the Space Weather Enthusiast dashboard, one thing to note here is the BTBZ. The BZ is in positive territory. Now, if that was -7, we would still be expecting additional time of geomagnetic storm and unrest. We're expecting the geomagnetic storm to subside in the coming hours here. There also is a forecast for additional KP4 geomagnetic unrest early tomorrow for the first 9 hours of the day there, universal time. You can see KP4 forecasted there. I believe that's for the ongoing coronal hole wind stream. If the BZ turns negative, once again, we could go right back into geomagnetic storm conditions. Let's take a look at global seismicity over the past 24 hours. Largest quake was this 6.9. Members of the SMASH team knew about this quite quickly. We even sent out an email alert about this one because there was a tsunami alert issued. No tsunamis occurred as far as I know, but when tsunami alerts come out, we don't screw around. We send out email alerts to even bronze members at the SMASH team, smashomash.com/SMASH team. So just before that, we saw a deep quake at Columbia. It was a 4.1 at 171 kilometers depth. By the way, that 6.9 out there south of Alaska was at 69 kilometers estimated depth. Decent quake in Indonesia there at a 5.7 magnitude. That happened at 12:34 yesterday, universal time. Some aftershocks there at Indonesia, some aftershocks at Alaska. Some magmatic quakes likely happening at Hawaii there. A 5.8 in the Kuril Islands region there, south of Kamchatka, north of Japan. That was a 5.8. That was, I think, the second largest quake of the past 24 here. And if we miss anything in the report, let us know in the comments. Thanks everybody who leaves comments. A couple additional deep quakes happening early this morning, like this 5.1 at Columbia and this 5.4 north of New Zealand there, near Vanuatu and near Fiji, actually. Estimated depth there, 522 kilometers. Let's check volcanoes. Has somebody been trying to check your oil? Well, let's check the Earth's oil by looking at volcanoes. La Palma's still erupting. Calming down a little bit. It's now a 6,000-foot plume of ash. I think downgraded from a 10,000-foot ash plume yesterday. Semeru on East Java. Flight level 140. It's a 14,000-foot plume of volcanic ash from Semeru, Popocatépetl. Exploding 20,000-foot ash plume over central Mexico as the area northeast of it gets fertilized with volcanic ash. Fuego exploding, flight level 160. It's a 16,000-foot ash plume over Guatemala. Nevado del Ruiz appears to have dispersed its ash in the satellite imagery. Sangay volcanic ash also dispersed there. Revenador continuing to explode, producing a 15,000-foot ash plume over Ecuador, and Sabancaya reminding us not to pole vault the caldera as it explodes and produces a flight level 220 event, a 22,000-foot plume of volcanic ash. Check out our merch, by the way. You can find a link to the smAsho merch at the Smash shop. If you're going through hell, keep going. That's a quote from Winston Churchill. Have you celebrated last year's Dimension of the Year, unanimously voted Dimension of the Year, hell, for 2020? I implore you, universum liberate, and I implore you to make America not suck again. I'm currently wearing a Make America Not Suck Again shirt. So Mansa, yeah. Mansa, make America not suck again, please. As it's been sucking pretty hard, people doing a lot of stupid things, like seemingly intentionally destroying the economy. By the way, who's responsible for making it not suck? Who is it? Is it the World Health Organization? Is it a government? Please! Today's featured product is the classic tea in purple. So yeah, tell your friends and foes to make America not suck again, as it's been, let's just say, a little bit sucky in the past couple of years. Welcome to the Neo Renaissance. Visit our own homepage. Support the channel via the links below the video. Thanks for everybody who does. To the rest of you, sorry you haven't joined the Smash team. You probably should. You'll get all kinds of information nobody else gets to see. Let's take a look at information somebody's going to get to see, like 5 people on YouTube. Thanks, algorithms. Here's the GOES magnetometer over the past 3 days. And we see some arc jet moments here. This is when the GOES 16 or 17 has to turn on its thrusters to make sure it's in the proper orbital spot. And these spiky readings you see here are the arrival of both the coronal hole wind stream and the coronal mass ejection. So this area right here, this is the coronal mass ejection portion of it. Again, we are expecting to see that subside there as we are seeing the magnetic field shift and some other factors we'll look at in a moment. The real-time solar wind. First, the magnetic fields associated with the heliospheric current sheet. I say associated because I don't want to say caused by. Chicken and egg arguments in physics matter, folks, which is why I don't say caused by. Unless I think something's really caused by something, I usually say associated with, because correlation does not necessarily mean causation. Anyway, here's the latest image, Earth solidly in a South Pole current sheet shown here in red. Here's the line of sight view of the same data. We're not expecting any sudden changes. Not expecting any sudden changes in the heliospheric current sheet polarity at the moment. We're expecting to remain in the South Pole current sheet tomorrow. Here's the line of sight coronal hole plot, and we're going to show you some additional imagery here of coronal holes. We see some well-defined coronal holes rotating here into the Earth-facing zone here from the south. Anyway, here's some imagery. I just wanted to show everybody the coronal mass ejection associated event, because there was a flare on 10/9. Associated with, there it is, there's the solar flare. It was an M-class flare. It even sent some relativistic particles toward Earth. Here's that exciting event. You can see transverse waves spreading across the sun there. Just spectacular. Let's get to today's imagery. And here's today's imagery. You can see some diffuse coronal holes here, mainly in the southern hemisphere. Some more well-defined ones rotating in. They're tough to see from that angle, folks, because plasma is blocking the view of it. The corona is very bumpy, I'll just say that. And you can see that C-class flare causing some longitudinal waves as well. Not longitudinal waves, transverse waves. So likelihood of major solar flares is still there, folks. Solar flare warning remains, as Sunspot 2882 remains a beta-gamma class sunspot with a weird South Pole umbra that just sort of worked its way around in front of it. Quite an odd sunspot with that South Pole umbra leading. No, it's not a Cycle 24 sunspot. That's just not the way it works. So here's the GOES X-ray flux over the past 3 days. You can see this barely making it to a C-class there. Let's zoom in. And I don't think it was quite a C-class flare. Yep, it looks like it broke the plane. So, yep. I'll say that is a C-class flare anyway. We don't have any data on whether or not that produced a coronal mass ejection or was associated with a coronal mass ejection or not. We can see the proton flux here is subsiding as well. These relativistic protons here, they showed up only a few hours after that coronal mass ejection and M-class flare. Next, the real-time solar wind. And it's showing us a great signal of a coronal mass ejection. You can see all the panes here reflecting some activity there. You can see shifts in the phi angle. Check. Shifts in the BT/BZ. Check. Increase in solar wind density. Check. Simultaneous increase in solar wind speed. Check. Sometimes they produce a decrease in solar wind speed as well. Also a signal in the plasma temperature. Classic coronal mass ejection. Again, it is subsiding here a little bit. Current conditions are, by the way, this did occur during a coronal hole wind stream. Current conditions are 451 kilometers per second for the speed of the solar wind. Make it 463. Solar wind density, 10.47 protons per cubic centimeter. Now the BZ is shifting back down toward negative once again. We see a strong field here at a BT of 15. The white line is the BT 15. That is a strong field. If the BZ sinks back into negative territory, will remain in geomagnetic storm or unrest conditions. If this stays positive, we'll likely come out of geomagnetic storm or unrest conditions. Current status is a KP of 6. Each bar represents 3 hours. It's an active geomagnetic storm. Just about what was forecasted here also. Here's the magnetohydrodynamic pressure over the past 4 hours. This is our geospace magnetosphere movie. We show it daily, and typically not with this much pressure around the geospace. It is a high magnetohydrodynamic pressure environment. This is modeling nanopascals. It's 4 hours of data. We're also going to show you ground magnetic perturbations here, all the views that we have available. So there's your geomagnetic storm magnetosphere movie number 1. Here's number 2. Geospace delta B changes to Earth's B field. We also do see some power outages which may be associated with this. We'll get to it. There you can see it looks like a little bit of subsiding there of that. Let's make that full screen. So there's the North American changes to Earth's B field. Whenever you see the word delta in science data, folks, that means change in geospace delta B, changes to Earth's B field. Here's the global view. This does give you the likely, this does show you the most likely spots where power outages would occur, also auroras. So quite a magnetically active geospace here during this geomagnetic storm condition. If you get photographs of the aurorae, let us know. We'll gladly put them on the video. And here are the polar views. Let me make it a little bit smaller here. There we go. Each one of these is 4 hours of data, folks. We just wanted to show all the views here as it is a current geomagnetic storm condition. By the way, notice how you still have the internet and you're probably just fine. Don't worry, folks. The sun is not going to kill you. That's just nonsense. Next, the Aurora forecast here. We want to show you the most likely places where auroras will be occurring. And we'll make sure we let this play all the way through here. Welcome to the geomagnetic storm conditions. And I don't think Tasmania is going to see any aurorae here. They were just outside of your purview there, it looks like. Continuing on. PowerOutage.us showing some power outages here in Michigan and Indiana. So that could be a result of induced magnetism. I mean, induced electricity in the power grid there, folks. Here is the empirical data. And you can see some pretty big spikes here in induced power. That's happening in the middle of the night, folks. It's not likely from things like air conditioning. It's actually pretty cold in those areas. So there you go. Some induced electricity there from weather from space. Let's see what's going on in space in terms of where planets are. Mars looking lonely. Once again, let's advance this 1 week. And there's where things will be in a week. Mercury coming around to give Mars some company. Next, a star chart. I use in-the-sky.org. Mine's facing the south. I'm currently facing the south. What direction are you usually facing while watching our videos? Let us know in the comments. We've also drawn on the ecliptic, which is the yellow line here, the sun's path across the sky. The blue line is the galactic plane. Today, the sun will be traveling through Gemini and Taurus, and it will be south of Aries from this location. Today's cosmology segment will be brief. Starting out with this article, full of mental gymnastics and insanity, as far as I'm concerned. This is just, first of all, let me just say something controversial here. I do not believe that the Laser Interferometry Gravitational Observatory is measuring gravitational waves. That's the first thing I'd like to say. There are a lot of arguments that are valid arguments as to why this isn't science. And the way they tie these, quote, gravitational wave and, quote, events to astronomical phenomenon is absolutely ridiculous. What they do is when they, quote, sense a gravitational wave, end quote, they just look up in the sky and they say, did we see an X-ray pulse from any place or a gamma ray pulse? Well, that must be what it was from. That is literally what they do. And the amount of mental gymnastics associated with all of this stuff, the way neutron stars merge, the way they blow off shells, the way they explode, what supernovae are, helium stars, etc., has never been observed. It's all completely based on conjecture. It's based on the standard concordance model of stellar evolution, which is making less and less sense. It doesn't add up to any sort of legitimate observational evidence. It's all a bunch of math in search of observations, and these models are just silly. So, I mean, that's what I have to say about it. I'm just letting the article scroll here. It's from SciTech Daily. And again, the amount of mental gymnastics required to come up with this sort of stuff is beyond. This is not science. It is not science. Today, we're not going to look at a random object at all. We're going to look at Cygnus X3. This is science. This is actual measurement of hard X-rays from Cygnus X3. And look at its extended quiescent state. I want to see this covered by radio astronomy. I want to see radio telescopes cover this when it goes from its X-ray quiescent to X-ray loud state, as that tells us stuff about the giant plume of plasma in between us and this star. By the way, you're partially inside of this star's stellar sphere, Cygnus X3. If you don't know about it, go to our forum, smAsho.com/forum. The Cosmology Forum has an entire thread just about Deneb, the tail of the swan. Today's astronomy picture of the day is quite spectacular. It's a fireball over Lake Louise, bright enough to make a human shadow. Well done, Hao Qin photography. Just fantastic. apod.nasa.gov if you want to go check that out, download it yourself. It's a great computer desktop. Fireball over Lake Louise. We're also going to cover cosmic rays today briefly. Here's the Apatity Neutron Monitor and the Barentsburg Neutron Monitor, showing a downward trend over the past 30 days at Apatity. What about Barentsburg? A similar downward trend. Now, we cover these specific neutron monitors on purpose because they look like they have legitimate data. We're going to go farther south to Athens, Greece next. There is the Athens Neutron Monitor. A slight downward trend there at Athens. Almost flat there over the past 30 days. In fact, I think that might actually be a slightly upward trend at Athens, Greece. How about Mexico City going even farther south? A slight upward trend at Mexico City as well over the past 30 days. Let's also look at Oulu, Finland, and some Antarctican cosmic ray monitors. There's Oulu, Finland. Slight downward trend there. How about DOMB Antarctica? Slight downward, pretty flat at DOMB Antarctica. DOMC Antarctica, similarly flat. So that's our cosmic ray report. That's today's cosmology segment. Let's blast through more data as there's lots more stuff to cover. We got some charging hazards once again here over the Caribbean, northern South America, and Mexico. Surface charging hazards there. Moving toward the west. They'll be in the Central Pacific soon. Here's the relativistic electron flux over the past year from Solon.info. We've seen a minor increase. There's the 3-day chart from the GOES 16 and 17. We almost reached warning conditions yesterday. That's associated with 1,000 pulse flux units, or 1,000 particles per negative squared centimeter. And here's the forecast model. I would tend to agree that we're going to see little higher levels here. We may see electron warnings. The SMASH team will probably find out before everybody else. smAsho.com/SMASH-team. Here's a diagram of Earth's Van Allen belts. We covered a great story about it yesterday. Watch yesterday's daily space weather video if you weren't aware. Next, we'll look at the total electron content forecast. This is the electron density between your GPS satellite and your handset. Let's see if we see any chaos associated with the geomagnetic storm conditions. And we don't really see any chaos. We just see some very high levels of electron flux right around these moments, mainly over Southeast Asia. So some very high levels of electron flux there. Fairly brief. They subside rather rapidly as well. Yes, it's the Philippines, if you're wondering. Next, a diagram of the atmosphere to show you where the F-ionosphere layer is, because here comes your ionogram. And we see massive low-frequency anomalies during this geomagnetic storm. We scroll up a little bit there. All right, here's the latest image from 8:30. And here's the anomaly map showing you departure from the 30-day median. And you can see massive low-frequency anomalies spreading across the whole planet here. Planetary scale ionospheric anomalies, folks. And in many ways, the ionosphere is the bridge between Earth and space. You can see all those giant red blobs there. Those are all low-frequency ionosphere anomalies. Departure from the 30-day median. Oh, that's departure from yesterday. Let's redo that. So that was anomaly from yesterday. Now we're showing you anomaly from the 30-day median, which is what we usually show. For some reason, that got a little bit koofed. I apologize for that. There we go. 2 hours per second. And previous day is what we usually show. So some high-frequency anomalies showing up there as well. There's the latest image on the anomaly map. Some high-frequency anomalies showing up here over Southeast Asia. And there, indeed, you can see it makes it up to 14 megahertz there on the ionogram. Once again, there's the anomalygram. That's 8:30 Universal Time. Today's meteorology segment was epic. If you didn't see it, it aired before the daily space weather video. Here come our bonus features. The first bonus feature shall be the Lermonth, Australia latest hydrogen alpha data. Yeah, the sun from a ground-based solar observatory in Australia. There you go. A bunch of filaments down here in the southern hemisphere. Solar flare warning remains in effect. Coronal mass ejection watch or warning not really in effect. All eyes on Sunspot 2882. It's likely to produce major flare. So here it is, a close-up of it, and you can see multiple umbrae there around it. It looks a little bit like a paw print. And this other sunspot is setting. It'll lose its name today. Here's the latest colorized magnetogram. So we'll be down to only one sunspot group. There'll still be like 60 sunspots because of the way they're calculated. Here comes some additional bonus features. And this is 1700 angstroms. We realized that we'd be able to show you both sunspots here in one view, so we did so. Yeah, some spontaneous extra umbrae there appearing northwest of that sunspot 2882 there. So actually the likelihood of major flares has gone up just in the past several hours. Here's 94 angstroms, one of the best wavelengths. It takes 10 images per minute instead of only 2. You can see that C-class solar flare there. Here's 131 angstroms. This also takes 10 images instead of only 2. 94 and 131 angstroms are specifically for studying things like solar flares. Great view of that there, and we'll close the video out in 171 angstroms of that same zoom. Once again, thanks for tuning into the video, folks. Congratulations on realizing our channel exists. Visit the link, support the channel financially, as YouTube is less than helpful. And may that solar wind be at your back.